Logarithm. This is the last day in our unit. If we're talking agenda, you have to take the agenda on the board. Sorry, maybe I'll read this for the time. We're going to shift everything back today so that you will be testing on the 17th. We're spending 2 days to review because I really want high test scores. I want to be able to get your test graded before I leave that day because I'm not taking them home with me. The week after, just one second, the week after, so my media classes will test on the 21st, and then on the 22nd, you will learn 9.1, which is a trade review. This is how that may work. And on the 24th, I forgot about that today, we will either learn 9.2, but I don't know if I trust doing that without me actually. It'll be me teaching it via, like, it's kind of like watching one of my videos. But it's a little bit harder. So I don't know if I feel fully comfortable teaching you that one that day. I might rearrange it in 9. I don't know. I'll look at it. I'll either rearrange the unit 9 sections, or I'll throw in, maybe I'll throw in like an ECC test day where it's a video skill, so we can do a bunch of ECC questions. Because the next week, you'll be taking them after ECC. Do you like that idea? I never emailed back to me. I can go back to one better. Start the conversation.
Very taken it. I am leaving the 17th after school. And I will be back. We pick up our rental car on the 17th. We're not telling our kids, which is really hard. And no, we're going to San Diego. Still a little bit of land in San Diego too, but and then we come back to 26th. Wait, hold on. Sorry, this is recording. It has nothing to do with anything. You have a salary for a reason that probably people.
Well, you can think stuff about your strengths.
Well, now you've all learned a little bit about it. Really quick review. How do I solve these equations? Part A, what would you do? Okay, so you have to isolate the radical, right? So meaning do it by itself. Add the 4, so square root. No, not going to work. Square root 2x minus 3 equals what? 3. Then what? Square it. So you get 2x minus 3 equals 9. Then add 3, 2x equals 12. And then x equals 6. And then you plug it in here just to make sure you don't have a negative inside the radical. Do we? No, so we're good. Okay, how would you solve the quadratic? It's been a while. How do you solve the quadratic? Yeah, perfect. Set it equal to 0. So add the 12 over. X squared plus 7x plus 10 equals 0. Then what? Yeah, we play the game. What multiplies to 10 adds to 7? Good. X plus 2. X plus 5. Then what? 7 equals 0. So x equals negative 2. Or x equals negative 5. So major review. Today we are solving equations. Now with the quadratic equation, this one, you had to break it into multiply, solve individually. With the square root equation, you had to cancel the square root by squaring it. There's always a process of solving each equation. You have to undo certain steps. Now the same is going to be true if you have exponential equations. There's a couple of ways to do it. Let me show you my favorite. So I think that I would skip step 2. I don't know that it's necessary, although you could do it that way. I think it's confusing and you're likely to make mistakes. So if I want to solve this equation, I'm going to write it a little bit bigger off to the side, but when I do it, the very first step is to isolate the exponent. So how do I get rid of the minus 2? So can I say 16 to the 3x equals 8? Is that okay?
A little bit Chinese, do the best you can. Now, if there was a way to get the exponent to come out front, I want to do that. Did one of our properties yesterday enable us to pull an exponent out front? Yes, what is the power property, I think is what it's called. So if I were to apply the log to both sides, could I take this 3x and move it to the front? Let's do that. When I do that, I've got 3x times the log of 16 equals the log of 8. First thing I want to do is cancel the log of 16. It's connected to the 3x by a multiply. There is another way to do this, so if you can see how to do it in one step, go ahead. You don't have to ask permission. If I divide both sides by the log of 16, I get 3x equals what? Will you plug this into your calculator? The log of 8 divided by the log of 16. I didn't really worry about the change in base. Like, I didn't worry about using base 16 because my only goal is to get that 3x up front. So I could use any log I wanted to. I chose the common log because you can just plug it into the calculator. So give me maybe 3 decimal places.
3-4.
I got 3/4, I got 0.822 or 71.
Oh, that's if you divide by 3, that's 1.
Okay, so I've got 0.75, and then we divide by 3, we get what? 0.25? So our whole goal for today is to solve these equations. Again, there's another way to do it using that step 2, and I could show you if you really want to know, but I think that if you just do it one way the whole time, you're going to be more successful. Plugging this into your calculator. All right, so you're going to isolate the exponent, log both sides, pull any powers in front, divide, circle, circle, and move on. So let's do it again. Part A. That exponent is already isolated. So how am I going to move that 3x to the front? Let's log both sides.
Do you want fraction or decimal?
I really want to want to. As long as it's the correct one. So then this 3x can come out front, right? So you've got 3x times the log of 27 equals the log of 81. Now I noticed a few things about the 27 and the 81. They're both powers of 3, right? So I probably will get a nice pretty number here. I mean, it's probably decimal, but it's not going to be anything terrible. So let's divide by the log of 27. The log of 27, 27 cancel. You'll get 3x equals what? 3? 1.33? Okay. And then, how do I get rid of that 3x? Divide that by 3. And 0.4 repeating? So, Brandon, when I grade this, and you put 4/9, I know that 4/9 and 0.4 repeating are the same. So either one will work. On the homework assignment, the only reason I really cared, on the homework assignment, I put the answers in I don't know. I'm just going to instructions. Yeah, just recording it. Most of my answers on the homework are decimal. There's one that I like to get back to. So, just so you're aware, Brandon, and you're grading your homework, and I have it as a decimal, and you have it as a fraction, make sure you convert it. Yep. Okay. Cool. Part B. How do I get that exponent out front? Log both sides. Good. So log, pull the whole power out front. Be really careful how we write this. Negative 2x plus 2, put it in parentheses, times the log of 3 equals the log of 81. Now what do you do?
Log 3,
Divide by the log of 3. Oh, just kidding. Hold on. Okay. And again, 3 and the 81. It feels like there's a lot in common there. So you're going to have negative 2x plus 2 equals 4. Then what? Subtract the 2. Negative 2x equals 2. X equals negative 1. Any questions with that? Either of those three? Okay. Now C and D are a hair different because this time both of them have exponents. If I log both sides, would it do the same thing? Yeah. It should, right? So it's going to be a little bit hairier, meaning ugly, but it shouldn't be terrible. Let's continue to log both sides. No, not until they're out of the exponent. So we got to log. Okay. Well, I'm not quite there yet, so I'm not sure. So we log both sides. On the left, the 3x comes in front. Log of 2 equals x plus 1 times the log of 4. Any questions with that? So we log both sides. We bring them in front. Then, let's divide both sides by the log of 2. Is that okay? Is the log of 4 divided by the log of 2 something pretty? Okay. So those cancel and you'll get 3x on the left. On the right, these cancel become a 2. And so you've got 2 times x plus 1. Pause for a second. Are you with me? Are we okay? Well, no, it looks like it in this case, but that's only because 2 squared is 4. They won't, not necessarily, no. So you just plug it into your calculator. Because these are both base 2, it came out to be pretty. And now you just solve it like a regular equation. The 2 and the 1, where? Right here? So if we distribute, I'm going to come back up here, there's not a lot of room, I'm sorry, 3x equals 2x plus 2. Subtract the 2x, x equals what? 2. And then we ignore this. Really quick, I'd like to talk about the domain of a exponential function before you try part B on your own. When we are doing a square root function, it looks like this, right? The log function, you know what that paragraph looks like? We've done it a few times, you remember?
Oh, yeah.
It comes up like this, and goes like that, right? What's the domain of this function? 0 to infinity, right? What's the domain of this function? Does it ever go this way? Nope, so it's from 0 to infinity. In fact, will it ever get to 0? No. So I'm going to put a parenthesis here, which means all of your answers, you're never going to have anything negative. Or when you plug it back in, that number can't be negative. So there's going to come an example in just a minute where we're going to have to take the square root of something. And normally when you're, pretend like it's 36, normally when you're the one putting the square root on, you're going to have a plus 6 and a minus 6. However, if it's a log, it can't be minus 6 because it doesn't go negative. Does that make sense? Okay. On your own, really quick, again, kind of ugly, but try part D. I don't experience it yet, but I'm not an auditory learning, so I would have to see what you're actually doing. You're gonna have to log both sides, right? Brandon, don't get frustrated with me. So we log both sides. We take the 2x, it comes in front, right? We got 2x times the log of the 25 equals, this comes out front, x minus 1 times the log of 125. And then what would you do next? You did that, and you're on the right track, but you're going to pause for a second, that's what the other thing.
So,
Turn it now. Oh, we're recording.
What's that?
I bet everyone else is
You're like, Brandon? I don't like that word, Brandon. No, not that one. Okay, I'll play later. Maybe I heard you around, I'm not sure. Retry it if you need more time. Alright, what's the first step? Divide by log of 25. You don't have to worry about the x minus 1, you can just cancel these. What? 1.5. So then you cancel those, 2x equals 1.5 times x minus 1. So now it's an equation that's a little bit easier. What do we do next? Distribute. Sorry, there's not a lot of room. 2x equals 1.5x minus 1.5. Subtract the 1.5, so you have 0.5x equals negative 1.5. X equals negative 3. We don't have to really worry about the x being negative 3 here because it was part of the exponent, not part of the log. So we really have to worry about if it's like log of x. If I got that and said x was negative 3, then I would worry about my answer. But because the x here was an exponent, can exponents be anything? Yes, so my answer here is fine. It's when it's inside the log, so I guess I didn't need to bring that domain issue up yet. Because this is an exponent question. If I'm dealing with an exponent question, so I have an empty space, the graph looks like this. What's the domain of that graph? All real numbers, right? So it's okay for that one to be there. Okay, next page. You can ignore that one. It's doing the exact same thing as we were. So let's jump to example 3. On your own, you can try it. Did you finish? Not yet. Did you eat? You can try right in my garbage bin. So we're gonna have lunch.
That's hilarious.
Is this last to do that? Fantastic. Well, we can finish before lunch.
That'll make you feel
Fantastic. I think we only need to do 2 of these. Or maybe even maybe, yeah, A and C. We'll do A and C and then move on. We'll do how do we get the goal?
which one are we supposed to be doing?
Okay, just to make sure I'm clear, I may not have been on this one. When you're isolating the radical, that negative is part of the isolation. It has to go away. So the very first step is to get rid of that 5. How do you do it? Subtract 5. to the point that you can log both sides.
But can you insert it?
So log, the x comes out front. So you've got x times the log of 3 equals the log of 45. And you want to get x by itself? So divide by the log of 3. So x is what? I think if you round to 2 decimal places, I'll have enough information to say you got it right. Knowing that, will you try part C? It's annoying. Part C. C. Part C.
Hey, it can be more.
Part C, please. Go ahead and math and application is required.
Yes, I do.
I do it for the parabolas. An x and an e? What's an e? Is e a variable or is it a number? It's a number. Just like the other ones, you just have to use the natural log rather than the log. So, but I'll show you. Yes, Jessica. Okay, great. On this one, first step. Guys, first step is to get rid of the what? The 2. So 4e to the 2x equals 14. Now what? Not yet. Divide by 4. E to the 2x equals 5. Now you're to the point where you have to cancel the e. You could log both sides, do the same thing you were doing before. However, do we have a special log that would cancel the e? Yes, so let's apply the what? Natural log to both sides. Can you still natural log to 3.5? Yes. On the left, the natural log and the e will cancel because they're inverses of each other. And 2x equals what? What's the natural log of 3.5? 1.25? Where? Now I've got 2 times x equals 1.5 or 1.25. Now we do what? Divide by 2. So x equals 0.6. It's still ish because we rounded this one. Yes, Brandon. Did you log both sides or did you natural log both sides? Because you still will get the same answer if you do it right. However, it's faster, and I know you like faster. It's faster to use the natural log. Hold on, let me finish my sentence. It's faster to use the natural log because the natural log and the e will cancel completely. So you don't have to move anything to the front, but it's just 2x. Well, not 4. 4 has to divide out first. You have to divide it. So you have to isolate this first. The 4 is part of what you need to get rid of. Just to make sure you're clear with the E, part D, the very first thing on part D would be to do what? Minus a 5. So you have E to the 3x equals 10. Now, we have that E function. How do you cancel the E? You natural log it. So the natural log of E, they cancel. And you have 3x equals whatever the natural log of 10 is. 2.3. Okay. And then divide that by 3. And on your calculator, I wouldn't even retype the 2.3. Once you get that 2.30 ugly, just push divide 3. And then you're not rounding anything until the very end. X equals point.
Yeah.
You have to be round. Ish fixes everything, right?
I did that on my desk.
No.
You don't have.
Although I think you guys already asked. Okay, now let's do the reverse. Let's get it done in 10 minutes, so when we come back, the entire time will be to finish up your Unit 8 packet. So we'll take the roll, and the whole time I can give you the answer keys. You can start looking to see if you got things right or wrong. I can fill in any gaps if you were absent for a few days. And we can actually start our review today. So by the time we're done with this, you're going to know logs like you were the one teaching it. That's the plan. We want 100%. Okay. Might be wishful thinking, but we're going to try. Part A, how do you suppose we do this? The first step, just like up here, when I isolated the exponent, on this one you have to isolate the log. Now right here, everything is inside of that log, right? So the log is already isolated. What's the base of that log? The base is 10. So how can I cancel the 10? The base 10. So I don't know what the right math word is for this, but I'm going to base 10 both sides. So the problem is now the exponent, the base is now the 10. Is that okay? The problem is the exponent, the base is the 10. And the 10 raised to the log, those cancel. You got 4x minus 3 equals 10 squared, 100. No longer in the exponent. When the log and the 10 cancel, they come down to the bottom. Okay? Then we add the 3, so 4x equals 103. Divide by 4, x equals 25.75. Now really quick, you need to check. Because remember before I said the logs have a domain restriction? If I plug this in, is it negative?
Probably not.
No. So you're good. The answer is almost always probably not, so I guess you're safe. But there is a risk that it could be, so it's worth trying it. And you just have to look at it. I don't need you to like do anything weird. Just check to make sure that number inside of there is positive. Okay, again, is the log already isolated? Yes? So how do I cancel a log? Base 10. You're going to 10 both sides. Okay? Those cancel. Then you have 3 minus 2x equals what? What's 10 to the negative 1? 0.1. Very good. Now you subtract the 3. Is that okay? So negative 2x equals negative 2.9. Divide by a negative 2. So x equals 1.45. If you plug that into here, is this negative? So 3 minus, it's really, really small, but I don't think it's going to be negative. So we're good. I think the only time you really have to worry about it is if there's an x squared inside here. Okay, let's keep going. Part C. This time is the log isolated. No, so the first step is to do what? Get rid of the 2. So we divide by the 2. We have log of x plus 1 equals 2.5. We divide it 2. Then I have to get rid of the log. How do you do it? Base 10 both sides. Those cancel. And you have x plus 1 equals 316.23. Subtract the 1. Ish.
How would you get the 2 log and 2.5?
2.5 decimal. Sorry, divide by 2. Jessica? So the 10, like, are you saying right here?
Yeah, like how did you get the 2?
You plug 10 to the 2.5 as an exponent into your calculator, you get the 3. The 10 squared is 100, but 10 times the 2.5 is 3. cancel a natural log this time, so what are we going to do? We're going to p both sides. So this base e to the 0 is what? 1. Anything to the 0 is 1. So 5 minus 2x equals 1. Negative 2x equals negative 4. So x equals 2. What about part E? Part E, we're going to maybe have to square it. There's a couple ways to do this one. I probably would take the 2 and bring it forward. Can you do that? This is interesting. If you take the 2 and bring it forward, is that possible? And then, but that's one of the rules, right? If you take the x and bring it forward. So I'm going to do that first, because would you rather divide by 2 or take the square root? Yeah. However, you need to eat both sides before you can take the square root and then all this. Right? So would you rather divide by 2 or would you rather take the square root? Me too. So we're going to take this 2. Because this entire thing is raised to the second power, you can bring that 2 in front. So it's 2 natural log of 3x plus 5 equals 4. That's using the exponent power property. What we called it last time. Now it's 2 times the natural log of all that stuff. How can I get rid of 2? Right? It's already there. The natural log is already there, so we can simply move it. So then this is a log. Like ln here is a log. So natural log. Okay, so this is connected by a multiply. Let's divide the 2 out. So you have the natural log of 3x plus 5 equals 2. Now do we have the natural log isolated? Yes. So what do you have to do to both sides? E. Now we're ready to apply base E to both sides. That cancels. And you have 3x plus 5 equals e squared. What is e squared? 7.39. And then you solve it like normal. Subtract 5. So 3x equals 2.39. Yeah. What? I know, right? I don't remember where I looked it up.
Or something like that.
And x equals 0? It depends on where you can't do the log of 0. Log over 1 divided by log of 1? Yeah, that's fine. 0. Fantastic. What's 2.39 divided by 3? Fantastic. Now, I want you to look at part F. Here.
Well, my pencil showing where it stops, and my artist just gave me shit about it.
Oh, I can say something about it. I can say something about it. I can make a point.
So we're going to count part F different. What do you have to do this time? We have to do something. We have to do something because I can't just... I don't know what the right word is. What do you say? Do you both sides? I don't know how to say
I don't even eat both sides. You know I used to teach that way?
Okay.
I used to cook.
Are we
But
going
I
to
don't
do
do
that?
that anymore.
Show me really quick. Don't watch. Close your eyes.
Well, do you teach them how to go logarithmic from exponential?
Yeah.
So, if you're at that stage, and I'm just going to write one, of 5, or let's say x, is 7.
Okay.
So, I used to, right, and then you learn the law, and you do that, that's fun and new, but
Okay.
exponential, this is logarithmic, go to exponential. And I start doing this.
Well, that's how I told them how to do it. I mean, you go from logarithm to exponential, that's how I do it.
Oh, yeah.
Otherwise,
That's the memorizing thing that I make my kids do, but then they go like that. Well, they're mine, because it's like, it's so weird. I'm like, yeah, I know, but it's stop it up.
Well, you want to talk about
Welcome to the real world.
I'm glad for you.
I've been to Vegas, and I gave a guy that says, why lie? I just want a beer, so I gave him $5. And the other guy that's no water bottle told me.
Never staying on originality.
I don't care, but at least he was on. Sorry, Mr.
I want to go. You ruined everything. Have a good one. Okay, let's finish this up really quick. Part F. Did you notice a difference between part F and the other ones? They're expanded, right? And I can't just E this side when you got a bunch of stuff added together. So is there any way to make this so that they are not expanded? Can we rewrite them together? So this is what we did last time. When this has a multiply right here, you could rewrite it so it's 2x times 3x. Right here, because that's an addition, we can connect them with a multiplier here. Oh, sorry, when there's an add right here, you connect it to a multiplier. Sorry, what? It's because it has to do with this. You know when you have those multiplied together and you can add the exponents? So when these are added together, you can multiply these. It has to do with the exponents. Other than that, I've got a lot for you. I can explain the other ones just fine using that one, but it's hard to. Okay, so I want to show you something really quick. However, this entire thing was raised to the second power, right? So I could bring the 2 out. Technically, is there an x squared in here? We have x and x. So could you bring the 2 out? No, because the 6 that's in here is the 6 squared. If I rewrote that so it's the natural log of 6x squared, is everything being raised to the second power? No, so I don't want to bring that 2 up front. I want to leave it right where it is. Now, how do I cancel the natural log? You will apply base e to both sides. The natural log and the e will cancel. So you have 6x squared equals, what's e squared? 7.3. And how are we going to finish this off? Divide by 6. So x equals, it's the base. Okay, so 1.6. 1.2. Yes. And then what do you do? Square root it. Now, do you need the plus or minus here? Well, let's look. What's the square root of 1.23? 1. If this was negative, because technically to solve a quadratic, it will be plus or minus. If this is negative, hold on. Can you put a negative inside of a natural log? No. So do we need the plus minus? No, we just need the plus. Just the plus. That's when we care about it being negative, is if I'm solving a log equation, I can't have a negative solution because it's outside the domain of a log. Yes, Dominique. The squared comes because when we can combine these into one term, you have 2x times 3x. If I simplify that, I have 6x squared. Let's do another one like that. Part G. These two logs are being combined by an addition. If I wanted to write them with one log, what would be inside? X squared minus 3x. Now what do you think? That looks really ugly, but it's not too bad. What next? We're going to, what's the base of this one? 10, so we need to base 10, both sides. The 10 and the log will cancel. So you have x squared minus 3x equals what? Now how do you solve that equation? So it's a quadratic, which is what I was reviewing. That was the beginning. X squared minus 3x minus 10 equals 0. And then we, in the game, what multiplies to negative 10 adds to negative 3? Minus 5 plus 2. And if we solve that, x equals 5, x equals negative 2. Which one of those, if I plugged it back in, would not work in context of this problem? You can't have the negative 2 because you can't have a negative inside of a logarithm. So this guy goes away. X equals 5 is your final answer. On your own, why don't you try part 8? As a way to remind you really quick what I'm thinking about, if you wanted to fix your unit 7 test, tomorrow is the deadline. You haven't seen your unit 7 test yet. Because in order to fix, there's 2 ways to fix this one. In the future, I may not do 2 ways. There is a math Excel remediation that should close tomorrow. If you do the math Excel remediation, it's just 5% boost. So if you got an 80, you now have an 85%. If you got lower and you need more than a 5% boost, you can use that math Excel to help you review, and then you can come and take your exact same test that you had before. You have all of your writing on it, you have my markings on it, and you can fix the ones that you missed. So if I said that you missed 3 on problem number 2, you go back and you do problem number 2 correct, you get 1.5 of those points up. And so if you got an 80, now you can get up to a 90. If you got a 40, now you can get up to 70. If you don't want to, you don't have to. If you're currently not passing my class and you don't, at the end of the quarter, if you're still not passing, there's nothing I can do for you. If you have a B right now, you really want that A and you don't do anything at the end of the quarter, it'll smell very sweetly and it'll break my heart to look at it. There's nothing I can do for you. This is only for all aware of the situation. And if you do it all right the first time, you don't have to be fixing that. Go.
Is there a calculator?
Brandon, what have we already answered that? You got remember? Yes, there is a calculator. Yes, there is a calculator. This clearly would be on the calculator. You just have to get it back. I don't remember how long it is. I think it's estimated it takes about a half hour to complete. Mine estimated a little bit lower. All right, part H. This has a minus this time, so when we are trying to combine them together, it's going to be the log of what? 6 times 3x, 6 divides 3x, 6 to the 3x powered divide 3x. So because that's a minus, we combine it with a division. Equals a negative 2. And again, it has to do with those powers. Now, how do I get rid of the log? You 10 both sides. And you have 6 over 3x equals 0.01. Then how do I solve that? Multiply the 3x over. So you have 6 equals 0.03x. Divide by 0.03. So x equals can x be 200? Yes, that's fine. Did I record that? Yes. Fantastic. Thanks for watching. Peace out.